Go through the chapter test. This is chapter test 4, so that you are prepared for the test that I will send out to you sometime today. So let's go through this, and I'm also going to go through the chapter review. So if you haven't watched the chapter review yet, I didn't make it yet, but go back and watch it. I'll link it on the syllabus. So let's just hit them. So if triangle BAD is congruent to triangle TOP, then DB is congruent to what? And triangle TOP is congruent to what? So basically, if you don't even need to draw these. You can see that BA is going to be congruent to TO, AD is congruent to OP, and BD is congruent to TP. So it's going to be, or we can go in the other order. If they want BD, then it's going to be PT. So this one will be PT. I'm writing in red so that I can write in the blackboard too. All right, so that's the answer to that. And POT is congruent to DAB. You have to make sure the letters match. So this would be triangle DBA. Well, do they have these in opposite orders? Yeah, it has OTP, OTP, so we're going to go DBA. All right, one down. The next one says if EFG is isosceles with angle G equals 94, the legs are sides blank and blank, and measure of angle E equals blank. So if I were to draw this triangle, let's see if I have a triangle tool. I do. So if I were to draw this triangle like this, it's telling us it's not going to look exactly like this one because it's the only kind I can draw. But angle G, we're going to put that up here, and obviously this doesn't look like 94 degrees. But this one's 94 degrees. You could not have these two both being 94 because that would be more than one obtuse angle in a triangle. So I'm going to take 180, I'm going to subtract 94 from it, and we get 86, and we're going to share this among the two remaining angles, which would be 43. So this would be 43, and this one would be 43. So let's put the letters on here, EFG. So we'll just do EFG. So the sides would be EG and FG. And the angle E would be 43 degrees. So hopefully you tried this before you watch the video. You can pause it and do a problem, then watch it. However you want to do it, just make sure you do it yourself. All right, you want to prove, the chapter test is really easy for some reason. So you want to prove that triangle ABC is congruent to triangle XYZ. So I'm going to draw this over here. Let's see if I have a way to erase things on this. Whoops, I erased the wrong thing. All right. Well, let's see. Maybe I can't erase things without erasing the whole thing. So I'll just draw on this side here. So you want to prove triangle ABC. So let me do two triangles. And they're congruent, so I'm going to try to draw them congruent. Better than I do in class. Okay, so we have ABC, and we have triangle XYZ. And they're telling us we want to prove they're congruent. You have shown that AB is congruent to XY, and AC is congruent to XZ. So we have this. To prove the triangles are congruent by side, angle, side, you must show, so if we do side, angle, side, we could do either way, really. We could show that angle A is congruent to angle X, right? That's one way you can do it. So you could say angle A is congruent to angle X. Or you could do angle C is congruent to angle Z. No, you couldn't. This is the only way you can do it, side, angle, side. To prove that the triangles are congruent by side, 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 you must show that BC is congruent to YZ. BC is congruent to YZ. That's it for that. So just, whoops, if I do that, that erases. So let's not do that. So BC is congruent to YZ. A method that can be used to prove right triangle is congruent but cannot be used with other types of triangle is the hypotenuse leg method. That's where you have the hypotenuse and the leg. You have the angle, so it's really a angle side side, but because it's a right triangle, you can use it. All right, next one. Triangle CAP and triangle TAP are equilateral and coplanar. AP is a common side of the two triangles. So I drew this. I don't think I can draw this using their triangle feature, but I can draw it just using lines. So here we go. I'm going to draw it right here. So we have a common side right here, and then we have two equilateral triangles. You know, mine aren't going to look perfect, right? So we have two equilateral triangles. All right, let's mark it up. So these are equilateral, so this is the same as this, and this is the same. This is the same as this. And because they share a common side, we know that they're all going to be the same. AP is the common side, the two triangles. So we want to know the measure of, if they're equilateral, they're going to be equal angular, which means these are all going to equal 60 degrees. And they want to know what is the angle CAT. So we'll just make this CAT. And it's 60 and 60, so it's going to be 120 degrees. A segment from the vertex of a triangle to the midpoint of the opposite side is called a blank of the triangle. Okay, you kind of have to know your definitions for this. But if you have a triangle and you have, it goes from the vertex to the midpoint. Here's the midpoint. So let me just draw it a little bit different than what you might expect. So we have something like this. Okay, so it's going from the vertex to the midpoint of the opposite side. We can show that's the midpoint by putting these little dashes on there. This line right here is called the median. Now an altitude goes from the vertex perpendicular to the opposite side. And then we have a perpendicular bisector, which is a median and an altitude combined. Number 7, a point lies on the bisector of an angle if and only if it's equidistant from the sides. So I'm going to demonstrate that, though I'm running out of room on the side here. If you have an angle, here's an angle, and we have a point on the perpendicular bisector. So this is our not our perpendicular bisector, our angle bisector, which means we have a point on this. And if it's an angle bisector, it means that this is congruent to this. If that is true, then the distance from the sides are always going to be the same. Any point, this is going to be the same as this, or if we do any point on the side, this is going to be congruent to this. So the answer is sides. Okay, number 8. If in triangle ABC, A is 50, C is 80, AC is 7x plus 8, and BC is 38 minus 3x, then x equals. So I'm going to just squeeze this in here. We have, in triangle ABC, we have A is 50, and I'm going to do C first. So we'll put the C in here. Whoops, you can't see it there. I'm going to have to squeeze this right in here. All right, so we'll just do a little squeeze. Okay, so angle C is 80. So we'll call this C is 80. A and B. So if we take, and it's telling us that A is 50. So if we take 180, subtract 80, we get 100. Subtract 50, we get 50. We know that this angle is equal to 50 as well, so it's an isosceles triangle. So these two sides are going to be the same. If the base angles are the same, the opposite sides are the same. So this is 7x plus 8, and this one is 38 minus 3x. We set those equal to each other and solve. So we get 7x plus 8 equals 38 minus 3x, and we solve that, you get x equals 3. I think you can all do that. Okay, next ones are kind of fun. These are to tell why the triangles are congruent, which method. Is it side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg? So the first one, they're showing that these two segments are parallel, which means the alternate interior angles are congruent. So there's two different ways to prove this. You could also say vertical angles are congruent. So one way would be angle, side, angle. Side, angle. And you could also say that these two are congruent because they are also alternate interior angles. So you could also say it's congruent by side, angle, angle. Now you can't say they're congruent by angle, angle, angle. That's not one of the postulates. But we have angle, angle, side right here. All right, let's do the next one. So we have our vertical angles. So we can say this one's congruent by side, angle, side. Right? Actually, there's no. This one is a none. Because even if we can do that, this side is not congruent to this side. This side is not congruent to this one. So this one's actually a none. That was a little tricky because these marks are congruent. Let's say we could say this angle is congruent to this angle, but we can't get the two triangles congruent by any of the means. All right, this one we would say this is congruent to this. This is not hypotenuse leg because we don't have the hypotenuses, but we do have these angles are congruent, right? Because they're right angles. So this is an angle, angle, side. So an AAS. Let's move on. This one is, this is your hypotenuse leg because you have a leg in this triangle. You kind of have to flip this guy down and see that he matches up perfectly. So it's a right triangle, we have a hypotenuse and we have a leg, so this one is hypotenuse leg. These sides are congruent. So this one's a side, side, side. And this one's a little tricky. You have to separate them into two triangles. And you can see that they're going to share this common angle. So this one's going to be side, angle, side. Side, angle, side. So you have to pull them out and separate them. So we would have this side, and then we would have this side, and this side, and then the included angle. All right, next ones before we get to the little baby proofs. This one's telling us that WX and WX, this one right here, and YZ, this is a Z down here, cut off, are perpendicular. W is equidistant from Y and Z. The way you can prove that is we know these triangles are congruent by side, angle, side. So this side is congruent to this side. So they're equidistant, so you would say Y and Z. Z is equidistant from, now we can say these two triangles are congruent because they have the side, angle, side. So this is the same thing, right? So Z is equidistant from W and X. Name 4 isosceles triangles. All right, so this one is also congruent. These two triangles are congruent by side, angle, side. So isosceles triangles, we need 4 of them. So we would have this one. We would have YXZ, and we'd have YZ, YXZ. And then we would also have this one, WXY and WZX. They're isosceles too. So we named all 4 of those. And then how many pairs of congruent triangles are shown in the diagram? This is kind of tricky. So we have this one and this one. How many pairs? So that's 1 pair. This one and this one. 1. This one and this one, that would be 2. this one and this one would be 3, this one and this one would be 4, and then we have these big ones, 5, and then we have these side ones, so it'd be 6. So I'm going with 6. I think Slater says 2, but obviously there's more pairs of congruent triangles in this diagram. Everything's congruent. All right, let's go into the proofs. They're pretty simple. So the first one is, given angle 1 is congruent to angle 2, they're giving us so much. Angle PQR is congruent to SRQ. We're going to prove that PR is congruent to SQ. Okay, before we do anything, I'm going to pull them out, and we're going to, when they're overlapping, I would always redraw them unless you're super good at doing things in your head. So this is the first one, and this is Q, P, R. And let's draw the second one. Looks like this-ish. All right. Oh, I'm not good at drawing these. Not quite the same, but pull those out and let's label them. S, R, Q. All right, so those are our two. Let's mark them up. Angle 1, so this would be 1 is right here. This is 2. So angle 1 is congruent to angle 2. And PQR and SRQ. So this one's congruent to this. And we have to prove that PR, the big one, is congruent to this big one. Now the way you're going to do this is pretty simple. You can see that QR lies in both of these, so they're congruent. So I'm just going to put these are congruent. So we would say QR is congruent to QR, and that would be reflexive. And then we would say the two triangles are congruent by angle, side, angle. So a very short proof, very easy. All right, next one isn't that much harder. It's 3D, which makes it a little confusing. But we have these two triangles, so I'm going to pull them out. We have this middle line here, and we have these two triangles for right now. I'm just going to pull these two out, and they share a common side, like such. Okay. Oops, that line just kind of fell down on me. Oh well. Okay. So label them up. We have W, T, Z, and X. So the first thing I'm going to do is I'm going to prove these two triangles are congruent. So how do we do that? We're given angle 1 is congruent to angle 2. So this one is congruent to this one. 3 is 4, so this one and this one. And we have this shared side. So you would have WZ is congruent to WZ, and that's reflexive. So we can prove that these two triangles are congruent. So if the two triangles are congruent, then we can say this is congruent to this by CP/CTC. And then we have this sneaky little triangle going on back here. Whoops, this should have been a Y. Where did I get T? So we have this sneaky little triangle going on back here. There we go. And because these two sides are congruent, we know it's an isosceles triangle because an isosceles triangle has two congruent sides. So therefore, WZY is isosceles. And that's it. All right, so that's it for the chapter test. And I will go back and do the chapter review if you haven't already watched it.